In this video, I'm going to do something called proof by contradiction. Now, when you want to do this proof by contradiction, you basically in your proof do the opposite of the conclusion. In this case, the conclusion is then n is even. So basically in your proof, you'll assume n is odd. Now, proof by contradiction, it's very good because remember, even and odd are like two things, even and odd. So if you use odd and odd is false in like this whole proof, then it has to be even, right? If you have two numbers such as 5 and 3 just hanging around in the air, if a person picks number 5, the other person has to pick number 3 because that's the only thing left. Similarly with even and odd. If you do in your proof odd and you come false over there, that means it has to be even, right? So it has to be the other thing. So to do this, we assume that the conclusion is the opposite. So that means n is not even. So not even is it's false. It's odd. It's odd. So let's do that. So firstly, we write down proof, and now we do exactly what we should in the question. So now we're proving if n squared is even, then n is odd. So suppose, now you write down suppose. So suppose. So suppose n is odd, right? Then you must say what n is. So n will obviously be 2 times some number, so we'll say 2k plus 1. And because we introduce k, we must say what is k. So k is an element of integers. Okay, so if n squared is even, okay, so n, we made it odd. So let's do this proof. So we got n to be 2k plus 1. So put 2k plus 1 in n squared. So that will be, so put brackets 2k plus 1 all squared, because that's n squared. You're putting n in there. And if you work this out, will be 4k squared plus, remember it's squaring a binomial, plus 1. And now, you can clearly see we have to make this odd, because we said now we're proving that n is odd, right? So if we take out 2 as a common factor over here, you're left with 2k squared plus 2k, and then just put the 1 on there, and there we go. So now what you do is say 2 times a bracket with any symbol, so let's say 2m. And because we introduced m, we say m is an element of integers, and m is equal to this brackets, right? So just say that, and we prove that it's odd. Okay, so if we prove that it's odd, so now we basically proved it, because if n was odd, which we did over here, it will produce an odd number. It won't produce an even number. So that means, it makes sense, right? It can't be odd, this statement. It has to be even for this to be even. Okay, so just think about it. So now that we're done with the proof, we can say hence this is true. You just have to make like a square block and just color it in. That symbolizes that you're done with the proof. Okay, so again, we basically have to make this opposite. So we said if n squared is even, then n is odd. So we made n odd. So n is odd, this means 2k plus 1. So replace n here with 2k plus 1. And then you come to a conclusion where it's odd. Now because when you use an odd number, you get an odd number. At the end of the day, if n is even, then n has to be even when you put n in, if that makes sense. Odd gives you odd, then even gives you even. If this gives you an even number, then no matter what, this won't give you an even number. So it has to be even for this, if it makes sense. Okay, so that is proof by contradiction.